Hey everyone, and welcome to this video in the XDC Report. This video is going to be about the status dashboard of a blockchain. Now we're going to be using the status dashboard to understand the various parameters which a blockchain uses to measure its current performance. And we're going to be using the XDC status dashboard for this particular example. Although we're using that one, these concepts will be useful when analyzing any blockchain. So, getting right into it, let's go to the website for the XDC blockchain's status dashboard. It's zinfin.network, and once you hit that, you'll be able to get to this website. So, this is how the website looks when you first load it, and it takes a few seconds until all of the parameters get loaded because this website is live and it's pulling in data as we speak. So, it'll take a few minutes, and as you can see that all the block time transactions and everything have loaded. So now that the website has loaded, let's go through it one by one and understand all of the parameters and try to see what each one means. The first parameter you see here, which is probably the most prominent one, is the best block. And this is a very important thing to understand, that the best block is not necessarily the latest block. The best block is the last block which has been propagated throughout the network and is on every single full node's current blockchain. Like it's in the memory of every single full node. This is different from a block which has just been mined and has not been propagated throughout the network yet. So the best block is the last block which has been propagated throughout the network. The second one is average transaction rate. Now, although this shows 0 transactions per second, we can clearly see it's more than that because there are transactions that are happening. That's because this parameter takes some time to load. So if you let this website stay on your browser for a few minutes, these parameters will load completely. But average transaction rate tells you the amount of transactions that are happening per second on the network. The second thing is the last block. The last block tells us how many seconds ago the last block was created. And once the last block gets updated, the last best block that is, then you'll see that this number goes back to 0, as you saw right now. Finally, the average block time is again yet to load, but it tells you the average time it took to create the last X number of blocks. Then we come to active nodes. Now, what does active nodes talk about? It tells you the total number of full nodes which are currently present on the XDC main network and how many of them are currently running. So it shows that there are 242 in total, out of which 241 are currently running. We'll get into the Masternodes tab in a sec to explain this in a bit better way. The second thing is gas price. Now, gas price, as you know, is the amount of money you have to pay in order for a transaction to be processed on the blockchain network. It's like sort of a fee which you have to pay for the miners in order to get your transaction validated. Now, the full nodes here are not technically miners because they're not doing proof of work. This is a proof of stake algorithm. That's why they're going to be called a validator. So they're just validating the transactions. They're not performing any computation to find a nonce or something like that. Then this parameter, which is the max block size, talks about the maximum number of blocks, the maximum number of transactions which can be filled into one particular block. And let's say you have one transaction that has this much gas, then that block will only have one transaction. So that's what this parameter stands for. Finally, uptime tells you the amount of time this blockchain has been up for the last however many days this parameter is measuring for, and shows that it's been up for 100% of the time, which is a huge deal because there are a lot of blockchains currently which are very big public blockchains which do tend to have downtimes, and that's because of it being hacked or it being attacked by various parties. This is a huge problem because if you have a transaction which was very crucial and that's being made on a transaction network like a blockchain, which can be attacked very easily, then you would think twice before using that blockchain for transactions. But something which has 100% uptime is a huge deal. We can also see the block times, and if you hover over these graph bars, you can see that it shows the amount of time it took for the last block. So this is information which is being built live, and it also shows the number of transactions that happened in each block. It also shows the block size in way. Now, one thing to understand is you can see that all of these terminology which are used for gas are in way. it's being used, and the other blockchain which uses way for the gas price and everything is Ethereum. The reason that's the case is because if initially XDC was actually forked off of the mainnet of Ethereum, and that is why the gas price and all of these terms are similar to the terms which are used in Ethereum. So it's very similar to the way in Ethereum you would multiply the gas price into the amount of gas to get the total amount of gas which you are paying for a transaction. Finally, block propagation shows the amount of time in seconds needed for the block to propagate across the network. So you can see in the first 250 milliseconds, 34% of all of the all of the full nodes on the XDC blockchain have received a new block which has been created. And in the next 250 milliseconds, 66% of them has. So it shows that the rate, like the speed at which a block propagates, can be sliced into this. And you can see that by around the 2 second mark, all of them have received the new block. So that means that if a block is created at time t equal to 0, in 2 seconds after that, every single full node on the XDC blockchain will have that block. Finally, this is just a map showing where each one is located. And you can see that there's a huge clustering in America and the Europe region. And there's one in Japan, Australia, one in China, so things like that. And this is the list of every single one of these you see here. So you remember you saw 241 active nodes. Every single one of them is here. So you can see the name of it. You can see what version of the XDC client it is using, the latency of it, the peers, what block number it is on, the uptime, and all of these things. And this is extremely important because this adds a level of transparency to this blockchain where you can see exactly which validators are present on this blockchain. This is very important for a public blockchain because owing to its nature, it should enable a level of transparency for the person who's doing a transaction on a blockchain. Because I personally would not want to do transactions on a blockchain where I don't know who the validators are. So this is a huge deal. Speaking of the validators, let's look at the Masternode tab. Again, this Masternode tab will take a second to load. So once the Masternode tab on the status dashboard has loaded, you can see that it shows you all of the status of the blockchain at a bird's eye view, where it shows that the 108 masternodes, as we had discussed in a previous video, that XDC has 108 masternodes at any given time. They're all seen here. And the total number of nodes which are currently on the network are 207. This is the total number of staked ETH, which is around 2 billion, staked XDC, which is around 200 billion. And this is the epoch number and the block number. We had discussed epoch in the past as well, where epoch, you can combine multiple blocks into one epoch. And I think on the XDC blockchain, 900 blocks is one epoch. So any block from 1 to 900 would have shown up as within the first epoch, and so on. And then you can also see the various nodes here. So you can see the 108 masternodes which are currently being used. You can see 3 slashed masternodes. This is also something very important because if a masternode decides to behave in a way which is not conducive to the better, like the best interests of the blockchain, then their stake will be slashed. And that is why there are 3 slashed masternodes, which apparently must have behaved in a way which is not conducive to the blockchain. What they may have done may be anything that ranges from trying to sabotage the network all the way to approving a transaction which was not valid. Finally, standby nodes. These are the nodes which start to act as masternodes if any one of the masternodes goes down. So if this goes from 108 to 107, one of these will be randomly chosen to become a masternode. And these are 7 resigned nodes, which means they were nodes in the past who had deposited the amount of XDC needed to be staked. And now that they have decided that they want to maybe withdraw that XDC, they've stopped working as masternodes. So this is an overview of the network stats and the masternode of XDC's status dashboard. And in a coming lecture, we'll be exploring things along this in a bit more depth, where what we'll be doing is we'll be going through different parts of the XDC ecosystem, which is like the NFTs in XDC, the XDC, like XDSEA, which is the OpenSea equivalent of XDC, where you can trade NFTs, things like that. So let me know if there are any particular DeFi projects or any particular things within the XDC ecosystem which you guys want me to cover. Until then, this is Atharva Chandratre signing off, and I look forward to catching you guys in the next video.